All right, I'm going to have you do this bottom proof, but I want to review first what happened up here and then give you some clues for down here. So you remember we were trying to get these two angles to be congruent, but I didn't have enough information in these two triangles. When I looked up here at these little orange triangles, I saw that they were congruent by side, angle, side. And then if these two triangles are congruent, so up here, I use side, angle, side. Then I knew, well, if these two triangles are congruent, these parts have to be congruent. That was CPCTC, because it was part of the congruent triangle. Then I saw if we have these sides equal, these blue triangles are congruent by side, angle, side. And then lastly, if these blue triangles are congruent, the parts of the blue triangle are congruent. So the last thing I used was CPCTC. So you can kind of look through this proof and see first it was SAS, then CPCTC, and then we used right angles are congruent. That was that right angle theorem. We've talked about that a little bit now. That helped us get to SAS. And then notice here, corresponding parts of congruent triangles are congruent. That's CPCTC right here. So we're going to use the same kind of method, this double triangle method, to do checkpoint number 2. So if you look, we're trying to prove that this triangle, MYX, is congruent to this triangle, PYX. Well, what do we have? We have two right angles, it looks like, and they're sharing a side. So we've got an angle and a side, but we've got to get more information than that. So we're going to use these triangles to get more information over here. So if you want, go ahead and try it on your own. Don't look up here, but I will write some reasons down, or some statements, and see if you can fill in the reasons at least. So here's what we got. Go ahead, if you think you're up for the challenge, go ahead and do it on your own. If not, write in what I'm writing and then see if you can fill in the blanks. All right, I'd mark that in your picture too. You need to mark this given stuff in your picture. N, Z, Y, Q, Z, Y. Let's get all these right angles in here. M, X, Y, all of these are right angles. Okay. I'm going to say these are congruent. So first I'm going to get these small triangles to be congruent. Then once the small triangles are congruent, that's going to help me get things over here. So I'm going to label these. I think you should probably do the same. Let's call this 1, 2, 3, and 4. I think that's going to help you. Long one. All right, so pause the video, see how much you can figure out on your own, and then we'll go through it together. All right, so I hope you found all the givens. This was one big set of givens. And then yn, this was given. This was given. All right, so why are these two angles equal to each other? Why is NZY, why is this angle equal to this angle? Well, they're both right angles. That's your right angle theorem. If you wrote both are right angles, that's perfectly fine. So then why are these triangles congruent? Well, look at, we had an angle, and then we had a side out here. Now, we could have used the reflexive side, but they gave us this, so let's just use what they gave us. And we've got angle, angle, side. So that's nothing new. This you should be able to do. Now this is where it gets a little bit new for us. So 1 is equal to 2. Well, 1 and 2 are part of the congruent triangles. 1 is part of this triangle and 2 is part of this triangle. It's a corresponding part of the congruent triangle, and that makes it congruent. Now, how does that help us, though, with over here? And you're going to see. We've got 1 is equal to 4 and 2 is equal to 3. Hopefully you got that was because of vertical angles. But why is 3 equal to 4? Well, it's a long thing. If you look here, 3 is equal to 2, 2 is equal to 1, and 1 is equal to 4. So let me kind of write that over here. 3 is equal to 2, 2 is equal to 1, 1 is equal to 4. So we can cut out all the middlemen here and say that 3 is equal to 4, or congruent to 4, by the transitive property. So now look, now we've got another set of angles. So I hope you can now see what we're going to be using on these triangles. Hopefully you can already skip to that line and be like, oh, on the triangles, I'm going to use angle, side, angle. I already know that. We just need to fill in the missing parts. So xy is congruent to xy. That's reflexive. Then why are these two angles equal? Why is mxy congruent to pxy? Oh, because they're both right angles. The right angle theorem. That was quite a proof. Don't panic if you don't understand it yet. This one is a lot bigger proof than many things that you're going to see.